This is a Primary Math 5 class recording for week 1. We are talking today about, first off, we're going to do a little bit of an introduction of myself and my program, and then talk about the weekly plan that you'll be doing with your students each week. And then, of course, we'll talk about week 1 and how that's going to look, what you're working on this week. So in my introduction for this, I would like to first off, my name is Brenda Barnett, and I am the founder of Singapore Math Live. I started it this year, 2015, but my journey with Singapore Math started a long time ago. I actually grew up in Tulsa, Oklahoma, went to the University of Oklahoma and got a degree in mathematics. After that, I went and taught high school in public schools, actually in Texas, for 6.5 years. And then I started staying home with my own children. And in 2001, I started homeschooling and chose Singapore Math as my math curriculum. So my little guy started then, and I began working with him. And over the years that I worked with him, and I had 4 children total, and so with all 4 of my children as I worked with them, I really began to see and gain a huge appreciation for Singapore Math. And I'd like to tell you 3 short stories that kind of demonstrate my growth and understanding of Singapore Math. Early on, I was in a group of ladies, and we were talking about how long everybody had been married, and everybody just said, oh, this many years and this many years, and at the end of it, I said to people, wow, we have 127 years of marriage experience right here in this group. And they all kind of laughed, and they said, oh, Brenda, she's a math major, math teacher. No wonder she added those numbers up together in her head and did that mentally. And I thought, I knew, and I didn't bother trying to explain, but I knew that I could do that mental math because I had just taught my son 2nd grade Singapore Math. And by working with him, I learned some skills to think mathematically in ways that I had not done in previous years. In all my years of teaching math or getting a math degree or working in AP calculus, I did not think mathematically. I was just really, really good at doing math. And so that was an eye-opener for me, really. Then there was a time a few years later when my guy came to me, my little boy, and he was working on a math problem he couldn't do, and I looked at it and I said, son, I could write this problem as a 2-equation 2 unknown, and I could solve it in an Algebra 2 way. But you're a 4th grader and doing Singapore Math, and I don't think I'm supposed to do that with you. I don't remember, it was 3rd grade, 4th grade, whatever it was. And so I go away and let me think about how to solve this problem the Singapore Math way. And sure enough, I was able to figure it out. It took me a while, but I was able to figure it out. And then it became so obvious to me that although I, again, could do math, I wasn't thinking about math this way. And the Singapore Math solutions are so simple and so brilliant in their simplicity, and yet we don't teach children to think about the numbers in that way. And I had to learn to rethink and to understand math instead of just going straight to solving it, to really comprehending it. And it's made me better thinker because I did that. And finally, much later, matter of fact, recently I was doing an SAT online class, math prep class, and my daughter was doing the 6th grade Singapore Math series at the time, and my youngest, and she came to me and she said, one day, she said, Mom, this problem that I'm working in my book is just like the one you were talking about in your math class, in your SAT prep class. She'd be in the background when I was doing my prep class sometimes. And I looked at it and I said, she was exactly right. The Singapore Math Level 6 has a lot of thinking problems that are similar to the thinking skills that are tested in the SAT exam. And so the idea is not that Singapore Math 6 is a college prep class, except that it requires you to think mathematically in a way that prepares you to think that way. And much of college readiness is, can you think that way? So those stories are the brief snippets. I can go on and on, but I'll leave it at that. I love Singapore Math. I love what it's taught me. I love how it teaches me to do things and what we can do with your children together by doing Singapore Math. So weekly plan. What are we going to do every week as part of your class and with your student, and what are we going to do? How are we going to help your student learn Singapore Math? First thing that you need to do, if you haven't done so yet, is to print the syllabus from the website. You have a membership page. You can get on. You can print your syllabus and watch that, and have that in front of you. And every week, that just gives it to you by the week. How you schedule your weeks is up to you. You might have dentist appointments, or go to grandma's house, or go to the zoo. So I just put it down there for what all you need to accomplish during the week. And again, I'll let you know when there's something that you don't have to do everything or gets a little much or whatever. We'll talk about that. But that tells you kind of, if you want to do every problem in every book, that breaks it down into the 34 weeks of class. Actually, primary 5 is 35 weeks because I just couldn't squeeze it all in. And so so it breaks it down for you for how to get it all done in those 35 weeks. Then the second thing we'll do together is you'll attend class either live or in the recording. And if you are watching the recording and you're working on something, then I'm going to give you very practical help. I'm going to help you know what's going to be hard this week. What are the bumps in the road your student's going to come to? Where are the problems that they're going to find problems with, and let's talk about those beforehand so you can be prepared to answer those questions. What is essential? You don't have to do every problem in every book to be a good math student. If you're at home and you've got plenty of time, let them do more math. If they're gone too much and you need a little less math to do, then I'll help you know which ones you can maybe leave off. I'll also help you know how to verbalize the problems and how to visualize the problems, because much of the math is learning how to say it and how to demonstrate it visually and do that. And then, of course, you can choose, after you attend the class, we talk about it, you can choose to assign the pages by day or by week. Obviously, I've given to you by the week. You can break it down to your students, say, in order to accomplish this week, here's how much you're doing this day, and you can, again, take into account when you're home, when you're not home, when you have something else going on, whatever. The next thing that you need to do as a parent is to check the answers on a regular basis. Daily is great. You have an answer key for all of your books. It's one of the things I recommend that you purchase, and some of the answers in the back of the book, some is an answer key you purchase. But check your answers daily and go over the mistakes, preferably before they start the next day's work. Sometimes it happens every couple of days at my house, and that's okay too, but you have those available. And you can check the answers, because if you do a whole week's worth of work and you've done it wrong all week, that's no good. So take a quick moment, check the work. It's not much work to check daily, so you can just kind of look through and check the answers. Then, of course, you have, if the student gets stuck, the solution recordings for all the word problems. Now, the word problems that are in the intensive practice book and in the challenging word problem book, those are all worked out on solution recordings. Go on the website, click on the link, fast forward to the problems. You know exactly how to work it. I'm not going to have time to work all the word problems in this class period, but that's okay. I'll just do the introduction of things, and then the word problems are worked out very clearly on the recordings, so you can do that. And then the last thing I'd like you to do, I have to make a note over here, run out of room. The last thing I'd like you to do is to make notes of your questions. I'm doing this as a new thing. I'm not positive that I know exactly what you're going to have questions about, so make a note of your questions and send them to me. Let me know, what is it that is a struggle? What is it I need to make more clear as I go through things with people? And this is my phone number, 832-630-3321. I am in the Central Time Zone, so if you call or text me Central Standard Time, make sure that you are aware of what time it is at my house. And also, of course, you can certainly email me anytime, and my email address is very long but hopefully memorable, brenda.barnett@singapuremathlive.com. There's no spaces or underscores or anything, just singapuremathlive.com. Sorry, I had to break it down in two lines there because it's so long, but that's how you can find me anytime, and I'd be happy to work with you on things, happy to talk you through things. It is very important to me that I make this as practical as possible, and you can help me with that by letting me know what you need to know. One more thing that's very important to me is an analogy that I use a lot with Singapore math, and I call it my crawling and walking analogy, and here's what I propose. Watch a baby who is very good at crawling, goes zippity-doo across the floor very quickly, and then watch that child learn to walk. And what that child will do is they'll stand up and take 2 steps and fall, and stand up and take 2 steps and fall, and stand up and take 2 steps and fall. And what used to take them, 7 to 10 seconds to get across the floor, now it's taking them a minute and a half, because they have to go through the effort of standing up and then take a few steps, and then they fall, and it takes a while to stand back up. It goes on forever. but somehow intuitively they know they have to learn to walk. And a student who, or a 15-year-old, I've never yet seen a 15-year-old crawling around on the floor insisting that they're better crawling than walking, so they're going to continue with the crawl. Now, some of our babies take longer than others to walk, but eventually they all do learn to walk, and they realize, even though it's slower at first, that it's faster in the long run. And I think that's true of math, especially if you are starting. I really don't normally recommend that you start primary 5. Usually we start primary 4 at least to get the background, but the mental math might feel slower to do it, to add and subtract, multiply and divide mentally. But if you can cause yourself and your student to relearn the math and to learn how to walk mathematically instead of crawl. And by crawl mathematically, I mean when you if you add 15 and 7 and you go right to left and do 12 and that makes 22, that's crawling. If you add 15 and 7 and mentally you think, okay, 7 is 5 and 2, and 15 needs 5 to make 20, so that's 20 and 2 gives me 22. This may feel slower, but eventually this is walking and this is crawling. And personally, I was taught to crawl and I was never challenged to learn to walk mathematically. It feels slower in the beginning. Clearly, it takes more steps. It takes longer to write down. But when you learn to do that mentally, you can look at those numbers and 22 pops into your head because you've made your 10 and you've got your 2 extra and you're done. And writing a number down and going right to left is just very cumbersome in the way to do math. So I very much challenge you, even in primary 5, to start out doing the walking and not the crawling way of solving math. Okay, so now we're going to start with primary 5 and we're going to talk about the workbook. We were assigned this week to do exercises 1 through 5, and so I'm just going to talk about, sorry, talking and writing is sometimes more difficult than it sounds. Let's try again. That didn't help. Okay, anyway, I'm going to get this right. That's an E. Exercises 1 through 5. The first thing that we do in this book and in these pages is we begin to start talking in terms of place value. And it seems like we're starting very easy, and it is, but place value really has a lot to do with mental math. When you see a number and you really understand each number and what place it's in, it's a very good thing, and it will help you to do the mental math to see that. Another thing I want to make sure you know is that when your students are writing out the words on number 2, when they're writing out the numbers in words, the word "and" never shows up. Okay, we don't say 201, it's just 201. It's not 1,563, it's just 1,563. The word "and" actually is reserved for a decimal. And so eventually when we have decimals, we'll use the word "and", but when we say 105, what we actually mean is 105 tenths, and actually we'd usually say 105 tenths. But the "and" would mean a decimal. So just to be accurate and correct, don't have your student write the word "and". Make sure they don't do that. Also, again, if you've done Singapore math for a while, it may not be new to you at all, but there might be some value in this. Number 3. Part A, when it says the number 7 stands for, they mean it stands for 7,000, because in the number 27,685, the 7 has a value, or it stands for 7,000. Part B gives you the number 61,260, and it says the digit 6 is in the 10,000s place. I'm going to abbreviate. And the value of that digit is 60,000. So in the 10,000s place is the digit 6, and the value of the digit 6 is 60,000. So just making sure you're understanding the terminology that they use and how they make that all come together. The next thing, and that was all, yeah, the next thing I want to talk about is on page 9. So a lot of this is going to be intuitive to your child. Page 9 I like very much because it teaches rounding and it does it visually. So you can actually see that 297, if you're rounding to the nearest 10, is closest to 300 than it is to 290. And so the only thing they have to know, of course, is if you're at the halfway mark, the standard is you round up to the next number higher, but the rest of it, you can see on there when they break it down, they show you which way you're rounding. Rounding is an easy skill, but for some reason it gets people get very confused by it. And so, so there's just a lot of practice on it. On page 10, make sure they're paying good attention when you're rounding to 100 or to 1,000. They have you round to the hundreds. Then they have you round to the thousands. Okay, and again, you're just looking at the numbers. Let's do that a second. This is number 6A. If you have the number 4,385 and you're rounding to the nearest hundred, all you need to do is teach your student to zero in on the hundreds number and the one right after it. Those are the only two numbers they need to look at. When you see the 3 and the 8 implies you're going to go to a 4. Okay, so your 3 is what you're rounding to, the 8 is what you look at. Pay attention to the 8. The 8 tells you you're going to round up, and so then you have the 4,400. If you're rounding to the nearest 1,000, pick the right one to work on. 18,296, this is number 7C. If you're rounding to the nearest 1,000, all you're going to do is consider these two numbers, the number in the thousands place and the one right next to it. So when I look at the 8 and the 2, that 8 stays the same because the 2 is the number I'm considering. If it's 5 or higher, it rounds up. If it's 4 and lower, it stays the same. So when I write the number, everything else goes to 0, and that 8 in the thousands place stays the same. So that's a good way to teach rounding because you don't have to look at the whole number. You pick out the number you're looking at, the place value that you're looking at, and then you look at the next number to the right of it. Page 11. I'm going to spend a little bit of time talking about how to add, subtract, multiply, and divide mentally. And if you've done Singapore math for a while, this page may not be helpful or necessary to you, but especially for those of you who may be new at it, let's just talk about how to do numbers. We want to go left to right, not the right to left. Right to left is what we're taught in other math curriculum. Left to right is how Singapore does it. So if you have 27,000 plus 9,000, and I write it this way on purpose because you can ignore all of those zeros because you're just going with the place value. 27,000s and 9,000s. What you could consider this and say, well, I need, if I have one more, I can make that 9 into a 10. So now I have 26,000s and 1,000 and 9,000. These bunch together to make another 10, and that tells me I have 36 thousands. Or of course, when you write your answer, you would write it 36,000. I did not line up my digits, start right to left, and do this. Because once I get used to it, it's much faster to look at the two numbers that I have, to realize I can make a 10 if I borrow one of those over, and that means I have 3 10s and 6 1s, and that's the number of thousands that I have. What about subtracting? Well, if I have 53 thousands and I want to subtract 4 thousands, what we generally do, and again, we don't have to draw it every time. I always taught my children to think of tens as bars and ones as dots. So these are each 1,000. This is 53. If I'm going to take away 4, if I don't have enough room to take away 4 out of here, now, of course, there are several ways you can do it mentally, but let me just show you the basic way. The idea with this is I don't have 4 ones to take away. So I'm going to take the 4 ones out of a 10, and that leaves me with 6 ones left, because in earlier mental math, we learned very clearly that a 10 is a 4 and a 6. So if I want to get rid of the 4, what I have left is 6. And what that gives me is 4 tens, and I have 9 ones. So that gives me 49 thousands, or 49,000 for an answer. Now, you could certainly take away the 3's and realize you have to take away 1 more, and 50 goes to 49. That works fine on this one. It's not always as easy in that respect, but you could certainly do that one as well. Right? If you want to take away 4, if I'm going to take away 4, I take away these and take away 1 of those, which leaves 9 left. So I have 4 tens and 9 ones, or 49,000. In this particular problem, this way might be easier. Many times it's not, and you want to think about it in terms of just take all of the tens, all the ones out of a 10. Okay, but we just think in terms of that, and we work with the tens and then with the ones, and we don't do nearly as much right to left movement. On number 3, when you're multiplying, you have 800s times 2 is 1600s, which of course is also known as 1,600. So if you think of the hundreds as a unit and a place value, if you have 8 of those and you double it, then you have 16 of those. And 1600s is the same thing as 1,600. Same thing with division. A couple of ways to think about division. If you think of 1,800 divided into 6 groups, there's going to be 300 in each group. But then you might get to yeah, that's probably the best way. There's another thing for division we'll hit later, but on like 4C, if you don't recognize, that'd be the question. If you don't recognize that 5600s divides evenly by 7, what do you do with that? Well, let me write that up for us. You know, for now I'm going to stick with what we're doing here, because this is I'm going to save that next method for another time. Right now, the 5600s divided by 7 is going to be 800s, or 800 for an answer. And at this, by 5th grade, 7 times 8 is 56 ought to be a pretty obvious part of their math knowledge set. Okay, continuing on, when we do page 12, it doesn't say it overly clearly. Make sure you understand the squiggly equal sign means it's an approximation. Okay, it's not equals definitely, it's equals about the same as. And so when we do that, we're rounding. And notice in the book, one thing I don't like about Singapore math books, there's not many things, but sometimes it doesn't tell you how to round. Are you rounding to the nearest 100, nearest 1,000? What are you doing? In this case, because they give you the numbers in the example, then just follow suit with the example. And so they rounded to the nearest 1,000, so I rounded to the nearest 1,000. In the example, they went to the nearest 1,000, so that's what I did on each of the problems when I was working it. An interesting thing comes up on page 13, that's number 6, part F. An interesting thing comes up there. When you have 4,759, sorry, and you're dividing by 6. Many times when we just round to the nearest 100 or 1,000 or whatever it is. But when we're dividing, sometimes we have to be smart about how we're dividing. And if you think about sixes, if you count by sixes, and I had my children mentally think about factors of 6, or multiples of 6 actually, quite frequently, because being able to come up with multiples of 6 is a good skill to have. What you see pretty quickly is that 42 and 48 are multiples of 6. If I'm rounding this number to 100, would it be closer to 4,200 or 4,800? Of course, it's closer to 4,800. So when I divide 4,800 divided by 6, again, 4,800 divided by 6 is going to be 800. And so 800 is a good approximation. When I first looked at this, I thought my initial thought was to round it to 5,000 and divide it by 6. But the truth is, rounding to 5,000 doesn't do any good, because then I get a mess. So the only way I know to round to 4,800 is because I'm thinking in terms of factors of 6, and so those factors end up being 4,800. It works out really nicely. Yep. Moving on to page 14. 6F, I'm sorry, no, it's 1F actually. The problem we have here, you can't do, or probably cannot do, all the problems on this page mentally. We have 392 times 800 is the question. If I were trying to do this without writing it out with my child, I would potentially say, well, I would do this. 392 times 8 hundreds, okay? So 8 300s is 24 hundreds. 8 90s, this is 8 300s. Then I have 8 90s is going to be 720. I have 8 2s, which will be 16. And if I combine those, then I'm going to get, actually I'll have 3,136. This is still in the hundreds. So 3,136 is the same thing as 313,600. Now, that's all well and good. Again, I basically just broke it down into place values. If I have 8 300s and 8 90s and 8 2s, then I end up with this number, and I know that my units is 100. It is also perfectly fine just to take this, this is one that I say if you end up doing right to left on this one, that's okay. It's not that it's a bad thing to ever do it. It's that when we can do left to right, it's easier. And again, we just have to keep in mind that this is 800s. You don't have to write hundreds when you do it. You just have to make sure you have your answers in the form of hundreds when you get there. And of course, if you do have hundreds and you just bring zeros down and part of your problem, that's okay too. I'm not saying that all math done like that is a bad idea. I'm just saying that we want to make sure as much as possible that you're doing the thinking, the mental math behind it. Okay. Moving on to the intensive practice book. The intensive practice, I've assigned pages 1 through 5 to make sure that those pages are done. I've already said and talked about the fact that "and" needs to not be part of your words. It's on the, there's a lot more writing, I guess, in this book, really, that has it on there. So make sure there's no "ands" when you're writing out the material, the sentences about the words. On page 3, or page 2, actually, there's the value of a digit. They ask the questions in this way, but I'll make sure we see the value of the digit, what place is it in, and what it stands for. That's the 3 ways they ask these questions. So for example, in 3A, it says the digit 7 is in the what place. So of the number 62,718, 7 is in the hundreds place. So that answers what place. In 3b, it wants to know the digit. It gives us the number 352,806. And what digit is in the thousands place? That's the thousands place. So all they want to know is the digit is 2. It's just the number 2. And then when we look at part 3e, it says the value of the 2 in the number and the number that they give us. And the value of the digit 2 is 200,000. So just making sure you know how to talk through the digits and the values, all those different ways to ask the questions is a helpful thing. We do a little bit of number theory. So like page 3, number 8, let's talk about this problem. We're given the digits 6, 1, 0, 9, 2, 3, and 4, and we want to make the largest possible number and then the smallest number. For part B, the smallest number. Part C, the largest odd number. And then part D, we're going to do the smallest even number. So for the largest number, we need to have the numbers, the digits, in greatest to smallest, because I certainly want 9 to be, I guess we're going to have this in the millions place. I want 9 to be millions. I don't want 2 million. I want 9 million. And then I want 600,000 and 4 10,000s and 3 1,000s and 210. That's the largest number I could possibly have if I'm going to use all of my digits. But if I want the smallest number I could possibly have, now this is just a little bit tricky because remember, I can't put a leading 0. That doesn't count as a digit. So if I can't use the 0 first, I'm actually going to have to use the 1 first and then use the 0 in the 100,000s place. And then after that, it's going to continue going larger because 9 ones is fine, but 9 million is not going to be the smallest possible number. But then we get to the largest odd number. And we have to think, okay, if I want my number to be the largest possible, I still want to have the 9 in front and go from there, but I have to end in an odd number. Notice my largest number ends in a 0. That means it's even. But also notice that I have an odd number right next to it. So it occurs to me that if I have this same number, but I swap those two numbers, now I have an odd number, and it's still pretty large. It's not much smaller than this other number is, and it's an odd number. Same thing with the other one. If I want to have the smallest even number, the number I have here is an odd number. So if I want to have the smallest even number possible, I'm going to have a very similar number to what I started with. But I'm going to swap and make that 496 for my smallest even number. And we see that that works out to be a small even number. So it just gives it to us that way, so we have to work on it and see how it goes and just the number theory behind it. And the last thing to talk about in this book on page 5, number 16, again, kind of number theory question. If you have a number that's estimated to be 7 and you've rounded to the nearest 10, they want you to think in terms of what's the smallest number it could have been and the greatest number it could have been. If you round to 70, it could be as low as 65 or as high as 74. If you are at 64, it would not round to the nearest 10 up to 70. If you're at 75, rounding to the nearest 10, it would not round down to 70. And so each of those problems goes on and talks about that, but then you have to kind of round the corner and make sure you understand the way it rounds. So like, for example, it just takes some time to think about it a little bit. 73,000, if that's rounded to the nearest 10, then that number right there, notice I have 7,300 tens. If I went down one and had 7,299 tens and I rounded with a 5 in the next place, then that would round up to 7,300 tens. And by the same thought process, if I have 7,300 tens and I go all the way up to 4 in my ones place, it's still going to round down to 7,300 tens. Do you see how looking at things in terms of tens or hundreds or whatever helps us to round? If I'm rounding to the nearest 10, how many tens do I have? I have 7 tens. So if I start out with 6 tens and 5 extra, it would round up. Or if I have 7 tens and 4 extras, it rounds down. In the case of the harder one, part D, this is part D, this is part A, if I have 7,300 tens, then I can round down, or round down if I have 7,304 extra, or I would round up if I have 7,299 and 5 extra. So all of those are how you round and think about rounding to make it a little more concrete. Again, when you do the word problems with your child, I would highly recommend, I may not have said this earlier, but go through the examples together. There's just some good skills. It helps you to see things. It also teaches your child to read the instructions and not just start writing on the problems. But go through the examples one day. That's all I did with my children. One day we just do the examples, and then the next day I'd assign them some problems to do on their own. But that is one part of the program that I do try to sit down with my kids and just talk through the word problems. They did this, then they did this, then look what they did. Here's how they drew the picture, just to help them see it, because they do draw nice pictures and have really good visuals in the word problems. Okay, and so that's all of the information that I have for you for week 1. If you have any questions, email me or text me or whatever, and we can talk about it. And in the meantime, have a great week, and I will see you with material for the second week next week. Thanks.